Welcome back to Chemistry TV. Let's focus on a new topic which is called resonance structure. And this topic is one of the most interesting topic uh, in organic chemistry. It's very, very important to understand this because it's going to help you to understand what we call reaction mechanism. For those of you who are going to study chemistry in the higher level, what we call reaction mechanism. And this topic here is going to help you to understand how to predict strength of acid and strength of base. So it's going to be a series video. So this first video, I'm going to start with the fundamentals. What is resonance effect? What is the localized electron? What is the localized electron? Because these two things help you to understand resonance effect better. Then how to draw resonance structure. So I want to do some simple uh, how to draw resonance structure of what of molecule compound that can what exhibit resonance structure and how many resonance structure particular compound have. You guys, so you learn to watch to the end of this video, take everything step by step because these are stuff you are like go to see in the exam. So let's go into it. First, what is resonance structure? Resonance structure is the localization of pi electron into adjacent empty p orbital. I'll go back again. Resonance structure is the localization of what? Is the localization of pi electron into adjacent empty p orbital. So the moving of electrons in a molecule, like the moving of electron in a molecule, that we call what resonance structure. Another thing they may ask you or you will see in the exam is that resonance structure is the transmission of polar effects through pi bond. The transmission of polar effect through pi bond is now what resonance structure. I'm going to explain those things for you. So now, have you ever wondered why benzene they wrote benzene? They say benzene is having two resonance structure like this. Have you ever wondered why it's like this? Now, it's due to what the electron redistribution in benzene ring, and this is the reason why benzene is stable. So all the pi electron here are delocalized. What do you understand by delocalized? That is, they can move. This guy can move here, this guy can move here, and this guy can move here to produce other one here. But so many students don't understand this stuff here. So I want to take time to break it out step by step. So in order to understand this here, we have what we call two type of electron. One, we have what we call localized electron. Two, we have what we call delocalized electron. So if you can understand what you call localized and delocalized electron, then you are your way to master what resonance structure. So what is localized electron? You may ask. Localized electrons, these are pair of electrons or pi bonds that are restricted to a particular atom. That is, they are electrons that cannot be shared between two or more atoms in a molecule. And the main reason why electrons or pair of electron or pi electron or pi bond cannot be moved is because the adjacent atoms do not have an empty p orbital. Now let me explain to you. If for example here we have NH2, there we have CH3. Remember, carbon, carbon, the highest numbers of bond carbon can possess is 4, right? Now, because carbon is already having 4 bonds here, if you check it very well, here we have 1, 2, 3. Do you get that? Now this ammonia group here is having a lone pair. Now, this lone pair can either be this lone pair here can either be localized or delocalized electron because now one of the advantage of in organic chemistry is that is what electron movement together they can what donate what electron or they can what move the electron. So if you check this thing very well, this carbon here is already having 4 bonds. Three hydrogen are what one bond connected towards nitrogen. Now this electron is said to be what localized where you cannot move it to a certain point here to form a single bond. If for example here I should move this one here to form a single bond, this is what I want to get as a resonance structure. Here we have nitrogen, hydrogen, hydrogen because it's two hydrogen, right? So if I should put two carbon, like there's a bond connecting what? There's already one bond connecting what carbon. So let's just say hydrogen. Now there's already one bond connecting carbon and nitrogen already, right? And this carbon here is already having 4 bonds. So if she moves on here to form a double bond here, although this guy will satisfy to become plus, but carbon here is not satisfied. That is more than the octet. Do you understand? So in organic chemistry, electron will not be moved to a point where atoms will disobey the octet, especially what carbon. So because this electron cannot move here to form the second bond here, make carbon to be what? More than the octet. Because if you check it very well, carbon here is having uh 5 bonds. 1, 2, 3, 4, 5. Do you see that? So this is not possible. There's no way you can get this one. But in chemistry, you get. So now because this one cannot move here to form this other one here, this electron is said to be localized electron. Localized what electrons. So localized electrons are electrons that are restricted to a particular atom or two atoms in a bond. Do you get two atoms in a bond? Now there are electrons that cannot be shared between two or more atoms. Due to what? There is no empty p orbital at the adjacent atom. When it comes to p orbital, empty p orbital, that means the orbital, remember, p orbital can accommodate 6 electrons, right? So if the selection is complete, then there's no empty p orbital. But if the selection is not complete, then there's an empty p orbital, which I'm going to explain to you more. So if, for example, a carbon is having less than 4 bonds, do you get that? That one is not going to be an empty p orbital, which I'm going to explain to you. Don't worry. So we cannot move this one here to form a second bond. So this resonance structure is not possible. Because this resonance structure is not possible, this electron is called localized electron. I will explain on that one for you so you understand. So if, for example, here we have CH2 double bond CH3. If you check very well, now a pi bond is a what? Is a lone pair. Hope you understand. A pi bond is what? Is a lone pair. So yeah, I want to move this pi bond here to that point here to form a second resonance structure. Can I do that? If I should do that, this is what I want to get. CH2 CH, which is not what possible. Now remember, whenever carbon is not having up to the 4 bond or probably 3 bond, there's always a positive charge here. Understand that? So if I should move this one from here to here to form a second bond here, this is not possible. Like there's no way I can form this one here because carbon is having 5 bonds and this move here. And there's no way this one can be possible in what? Organic chemistry. So this pi electron here seen here is called what? Localized electron. Localized what? Electron, because it's not possible for them to move to each outside to form a second resonance structure. So this situation is not possible. So this is called localized electron. Hope you understand now. So localized electrons are electrons that are restricted to a particular atom or group, or they are bond that cannot be shared between two or more atoms in a what? In a molecule. Do you understand now? The important electron I want to look at is called delocalized electron, and this is called the foundation of what? Of resonance structure. If you can understand what I call delocalized electron, then drawing resonance structure will be much easier for you. And you understand how to apply resonance structure when it comes to what? Straight up acid and what? Straight up base. So what are delocalized electrons? Delocalized electrons are electrons that can be shared between two more atoms. They are not restricted to a particular atom. They are called electron redistribution. These are electrons like you can redistribute. I want to explain that to you. If, for example, here I've taken that example here, H2, here we have CH2 positive here. Look at this one here. Now remember, the difference between this guy and this guy here. Now this one, there's no empty p orbital because all the bond in carbon, they are okay. So carbon is already having 4 bonds here. So there's no empty p orbital, right? Now here, on the other hand, you are seeing here. Now carbon here is having 3 bonds. So let me do it like this. Having 1, 2. Now this plus here means that it have lost electron initially. So that is, it needs electron. So I can easily what? Move this guy to this one here. If I should move this one to this other one here, I'm not going to alter the octet electron. So carbon is still going to have the octet electron. So I'm going to still going to have the octet electron. So this is what I'm going to get. I'm going to have nitrogen here with 2 hydrogen, right? Remember this lone pair here that reside on nitrogen, I'll move here to form a double bond between what? Carbon, hydrogen, and what? Hydrogen. Now, whenever nitrogen forms a 4 bond, it becomes what? Positive. I want to understand this one here. Form a what? A positive. So that's why we have ammonium ion 4 bond here. Do you see that? So you can see that now, even when this one move here, it does not alter the what the octet electron. Do you see that? So now because this electron can be moved here to form a second resonance structure without altering the stability. Now this one is a second resonance structure, so that one here. Now this electron is called delocalized. Delocalized what? Electron. Now I want you to understand here is that this is the foundation in understanding resonance structure. So now the reason why so many students don't understand the reaction aspect of organic chemistry and some difficult aspect of chemistry is because they don't actually understand the fundamentals. So for each of my video, before moving to the advanced place where I explain question more, I always like explaining the fundamentals so that if you can follow this video to the end, things will be much easier for you. So that is the essence of this channel, of this video here. So make sure you follow me closely here because all these things I'm saying here are going to play a significant role in understanding resonance structure. After all, if you want to understand something here, you must go to the fundamentals. So this channel, I always go to the fundamental to explain what step by step. You can see some key questions you're going to see in your exam. So if you are not paying close attention or you want to skip this video, please don't try it. Make sure you follow to the end of this video. Or the localized electron. Now the main reason why it's called localized electron is because you can actually redistribute it to form a double bond without altering the octet electron. Hope you understand. Let's look at another one. Here we have CH2 double bond CH. Here we have CH2 positive. Now you should be sensitive here. Now this one here, I can move it to that point here. Then I can move this per electron. Do you see that? Which is a double bond there. I can move it. I should move it there. I'm going to add a second resonance structure, which is CH2 CH double bond CH2. Now remember I told you that whenever you are moving a bond away from carbon here, you're going to form a positive charge, right? Now, or whenever carbon is having 3 bonds, it's okay, you're going to be a positive charge. It's very important to put this positive charge here because if you go and write something like this for them in the exam, you have failed it already. It's okay because there's not like this. You get, because carbon cannot have 3 bonds. Now this one shows that it's seeking electrons. So the difference between this guy and this guy. So please pay close attention and take note of this. So now this electron is said to be what? The localized electron. So if someone should ask now, what is the difference between localized and localized electron? What are you going to say? Now, localized electron, you cannot move them as a result of the adjacent carbon atom or atom do not have empty p orbital to what accommodate that electron. Do you understand? So they are localized, they are restricted. White localized electrons, these are electrons that you can move to form a resonance structure. These are electrons that can be distributed around the molecule. It is what make the molecule more stable. I wish I'm going to explain more on that as we move on. So now that you have understand localized and localized electron, what's called resonance structure a little bit. So let's look at what the rules for drawing resonance structure. I'm going to explain 2 rules on drawing resonance structure, and that will be for this video. Then I'm going to give something for you to try. So what is rule number 1? Rule number 1 is state that move pi electron towards a positive charge or towards a pi bond. So here I want to say move pi electrons towards a positive charge or towards a bond. This is that. So now how do you do this one here? Let me explain to you. Let's take a good example. Just take some down. Take an example. In the exam, if they should ask for what to draw this resonance structure, how are you going to do that? In the exam, if they should ask to draw this resonance structure, how many resonance structure can you get from here? So we are going to take the first rule. Rule number 1, you should move a pi electron. This is called pi electron. Are you there? Pi electron. Pi electron is just like a lone pair. You get, move pi electron towards a positive charge or towards a pi bond. It means that you can move this one from here to here. It's okay. Then once you move to this other point, this one can move to this other point here. This is that. Now the main reason why it's like that is because at the end there's always what's an empty p orbital for to accommodate what the electron. So when this one moves to that point here, in order to satisfy the octet, so for example here we have this one here, hydrogen. So carbon, hydrogen. So when you move here, now carbon cannot have more than the octet electron. Just is that. So carbon cannot have what more than the octet electron. So when you move to the point to form a bond, a double bond here. Now this one is satisfied 4 electron, right? But this one is more than the 4 electron. So this guy have to move to that point here. So that as this movement is coming here, now this one is also move to that point here. The main reason why it can move is because there's an empty p orbital here, positive here. Carbon here is having what? How many electrons? 3 electrons. So you need 1 electron. This is that. So that is the reason why it can move to that point here. So when you move here to find this other way, this will not be here. This is that. So now we're going to come to this other point here, C, H. Now the main reason why like this is because it's still what get the octet what electron. So this is what is a resonance structure. This is called resonance structure. And when you are drawing resonance structure, use what? Backward and forward dot arrow, because you can still move it back like this, like this. You can still move back to get this structure here. Do you see that? So now you can see that when you this out. So here you can see that carbon is not disobeying the octet electron. Carbon is having what octet what electron here. Do you see that? So now you can still move this other one here. If I should move this one to this other point here, now what will happen here? This one will reside to this other point. So you are going to get a third resonance structure. As long as you can move it, you can get as much resonance structure. So here we have hydrogen, carbon, hydrogen here. So you are moved to that point here. So move to this. So when you move it to that point, here we have a double bond. You can see that. Now, these two bond here. This bond between these two here will now move here. Will now reside at this carbon. 1, 2, 3, 4. 1, 2, 3, 4. I just want to be careful so that I'm not going to make mistakes. So when you move it down to that point here, there's no bond between this face and second carbon again. So the double bond will now be formed between the middle carbon, two middle carbon here, two double bond here. Now this bond here will now reside at this carbon here, hydrogen. Now, one thing you want to understand here is that whenever electron moves into carbon here, it's going to form a lone pair. This is that, and it's going to be what? Negative. So this is what resonance structure. Remember, this carbon here must have a positive charge. Here, there's no other way I can draw this resonance structure. Rather, I can move it backward to get this one there, to get that one here. So here we have 3 resonance structure, 3 what resonance structure. Hope you understand. Okay, now you can go ahead and try this one for me. How many resonance structure can you pause the video and try this? So you can go ahead and try this for me. Go ahead, pause the video and try this. Let me see what you can do. Another rule here is that goal number 2. The goal number 2 state that you have moved a non-bonding pair of electrons towards a pi bond. Move a non-bonding pair of electrons towards a pi bond. So here we have this stuff here. How are you? Okay. Move a non-bonding pair of electrons towards a pi bond. So yeah, if I should move this one to this other point here, now what will happen here is going to have something like this. I will here see, right? So and there's no way carbon can have more than 4 bonds. So as you guys moving here we have a pi bond here. It's going to move to that point here. So when you move to that point, this one will disappear. Now the main reason why you're going to move because carbon is the priority, because carbon must not disobey the octet. So when you move some other one here, now this one will have to move to form a lone pair here, right? So here we have a positive charge here. So move what a non-bonding pair of electrons towards a pi bond. So that is it. Very important to understand this one here. So I'll give you one for you to try. Go ahead and try this one here. How many resonance structure can you get from here? Go ahead, try it. Let me see what you can do. So let's try it together. They say move what a non-body electron towards a pi bond. So I can easily what move this guy here. If I move from here, what will happen here? So move to that point. So I'm going to add what a second resonance structure, which is remember I have moved one here to form now going to form a double bond with carbon here, right? Now this one here we have to reside here. Here I have this one here. Does not change. So here we have under resonance structure. I can also decide to draw this guy too. Then I can also move. Now when this guy move here, here you still have to move to that point. This is that. So here I would have what a second resonance, the third resonance structure, which is the double bond here, right? Then this one, remember I move here to form. So in the sense that basically this structure is just having three resonance structure because if I should move some down here, I'm going to get this other one here. You get so just like what you are rotating what the non-bonding pair of electron, just that to get different structure. You can start this structure they look alike and they do not disobey the octets of oxygen and with carbon. So it's very important to know this here. So let's master the resonance structure for benzene. Now when we talk about benzene, how do you understand benzene structure? How do you understand benzene structure? How do benzene have that resonance structure? And the first one to do here is to what? Draw the carbon structure for what? Benzene. Remember benzene is having a triple bond, right? No, it's having three double bond. Benzene is having what? Three double bond here. Hydrogen, 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 hydrogen. Now, based on your understanding here, the benzene is what? Fully conjugated system. Fully what? Conjugated system. So, if I should move this one here, what will happen here? This guy have to what move here based on your understanding. This guy have to what move here. So, yeah, I want to get a second resonance structure because when it's move it here, this carbon atom cannot disobey the octet, so it have to move. It have to move. So here I have hydrogen, carbon, 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 or carbon, right? So here I'm going to have hydrogen, 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 hydrogen. So here we have this one here, hydrogen. Here we have hydrogen. Here we have hydrogen. This is that. So these are the resonance structures. So that is the reason why benzene has two resonance structure. Can you see that? So these are what the foundation of what resonance structure. In my next video here, we want to dive deep into complex resonance structure, how to draw complex resonance structure. If this video I'll be helpful, please leave at the comment section that this video will be helpful. Remember, you must know this one, then you must know how to apply it in solving what questions. So if this video is helpful, please give it a like and say this video is helpful. I really want to hear from you. Thanks for watching. See you in the next video.